Hi, this is Ramachandran from onlinemathforal.com. In this video, we are going to see solving problems on complex numbers. So that is, if there is a problem in complex number, how it can be solved. So let us consider the example that we have on the board. That is, if negative 3 positive I times x square times y and x square positive y positive 4 times I be complex conjugate, find x and y. So we have two complex numbers and it's clearly given they are conjugate to each other. If they are conjugate to each other, we have to find the value of x and y. It's okay. Now let us see how to solve this one. Okay, before we are going to see how this problem can be solved, so first let me write the given complex numbers. That is negative 3 positive I times x square y and x square positive y positive I times 4, because I've just taken parenthesis for real part and imaginary part for both the complex numbers. So because the part which has been multiplied by I is called imaginary part, the part which has not been multiplied by I is called real part. Okay, these two complex numbers are conjugate to each others. These two complex numbers are conjugate to each other. Okay, now I just tell you a simple example. 1 second. 3 positive 5i, 3 negative 5i. So what do you feel about these two complex numbers, 3 positive 5i, 3 negative 5i? So in the first complex number, so the sign of the imaginary part, the sign of the part in which we have the alphabet I, positive. In the second complex number, so the sign of the imaginary part is negative. So the signs are different, but otherwise we have 3 as real part in both the complex numbers, and we have 5 as imaginary part in both the complex numbers. So the sign of I in the first and second are different. So we will say these two complex numbers are conjugate to each other. So 3 positive 5 and 3 negative 5. So because they are different only in the sign of I, so they are conjugate to each other. So whenever I want to equate the two complex number which are conjugate to each other, I have to change the sign of I either in the first complex number or in the second complex number, not in both. So if I change this positive as negative, so it will become 3 negative 5i. Already we have 3 negative 5i on the right side, then both of them will be equal. Otherwise I have to change this negative as positive. So if I change the negative sign as positive, it will become 3 positive 5i. Already we have 3 positive 5i on the left side. So if I change this negative as positive, so this one and this one will be equal. So whenever the two conjugates are easy, and if you want to equate them, we just have to change the sign of the imaginary part in any one of the complex numbers, not in both. So for that, now what I am going to do is I am just going to equate these two complex numbers. 1 second. So I am going to equate these two complex numbers. When I do so, I have to change the sign of I either in the first or in the second, not in both. So now what I am planning is I feel this positive can be changed as negative, because these the given two complex numbers are conjugate to each other. So if I want to make them to be equal, I have to change the sign of I either in the first or in the second. I decide to change the sign of the imaginary part in the second complex number. So already we have positive, I am going to change it as negative. So please give me a moment. So it will be negative times negative I times 4. So the next step what we can do is negative 3 positive I times x square times y is equal to x square positive y. So I just take this negative sign inside of the parenthesis, so it will be positive I times negative 4. So students, please don't get confused how we have a positive sign, because I just took this negative along with this 4. so I used a positive sign here. So now these two complex numbers are equal. So whenever the two complex numbers are equal, so the real part of the first one and real part of the second one must be equal. Imaginary part of the complex number on the left side, imaginary part of the complex number on the right side must be equal. So now first I am going to equate the real parts. So negative 3 will be equal to x square positive y, because the real part of the complex number on the left is negative 3, so the real part of the complex number on the right side is x square positive y, and then the imaginary part of the complex number on the left side is x square y. On the right side we have negative 4. So I'm just going to rewrite negative 3 is equal to x square positive y as x square positive y equal to negative 3, and here I'm just going to divide by y on both sides, because I would like to have the value of x square, so that's why I divide by y on both sides. When I do so, I get x square is equal to negative 4 over y. I consider this one as first equation, I consider this one as second equation. So now what I am going to do is from the second equation, so we know that x square is equal to negative 4 over y. So the same can be applied in the first equation, that is in the first equation. So for x square we can plug negative 4 over y, which is equal to x square, so that we have in the second equation. So I'll just continue the problem on the next page. So in the first equation, instead of x square, I'm just going to take negative 4 over y, positive y is equal to negative 3. So to add this fraction an integer, I'm just going to multiply this y by y, will become minus negative 4, positive y times y will become y square over y is equal to negative 3. So now what I'm going to do is in this step I'm going to multiply by y on both sides. If I do so, y and y will get cancelled, so negative 4 positive y square is equal to negative 3y. So now what I'm going to do is I'm just going to take positive 3y on both sides. So when I do so, negative 3y positive 3y will get cancelled, so we have y square positive 3y negative 4 is equal to 0. Okay, so now what I'm going to do is I'm just going to factor this one. So if I, one second, so if I factor negative 4, positive 4 times negative 1, I think so this one will work for this equation, because the multiplication of the two factors positive 4 and negative 1 will be negative 4, the addition of positive 4 and negative 1 will be positive 3, which is the middle term. So the two factors are y positive 4 times y negative 1 is equal to 0. So we get y is equal to negative 4, y is equal to positive 1. Okay, if y is equal to negative 4, what will happen? If y is equal to 1, what will happen? So now we can plug y is equal to negative 4 in the first equation. So that is x is equal to x square is equal to negative 4 over y. So instead of y, I'm going to plug negative 4 here. So when I do so, I'll be getting negative will get cancelled, 4 will get cancelled. So I'll get x square is equal to 1. So x is equal to square root of 1. Since in front of square root always will have positive or negative, so x is equal to positive or negative 1. So we get x is equal to positive or negative 1 for y is equal to negative 4. So if y is equal to 1, so the same thing again I am going to apply in equation number 2, that is x square is equal to, one second, negative 4 over 1. So we get x square is equal to negative 4. So x is equal to square root of negative 4. So it's an imaginary number, and the square root of 4 will be 2. Since we have negative sign inside the imaginary number, inside the square root, it will be imaginary, so it will be positive or negative 2i. So for y is equal to 1, we get x is equal to positive or negative 2i. Okay, so I'll just summarize the result on the next page. So for x is equal to 1, so the first result is going to be so we get x is equal to positive or negative 1, y is equal to negative 4. This is one solution. The second solution is x is equal to positive or negative 2i, y is equal to 1. So these are the solutions we get of our question. So students, I hope now you will be able to understand how this kind of problems are solved on complex numbers. So the most important thing what we have to remember in this problem is if two complex numbers are conjugate to each other, and if you want them to be equal, so we have to do a simple work. We just have to change the sign of the imaginary part for any one of the complex numbers. So once you change the sign of the imaginary part for any one of the complex numbers, so those two complex numbers will be equal. So once the two complex numbers are equal, we can equate the real parts and also imaginary parts. From this from that we can get answer for x and y. So okay students, for more videos like this, please visit www.onlinemathforall.com. Thank you.